Hi there. People were working on these two proofs in class today. Today is Friday the 18th. And although I saw some good steps, we didn't really go over them as a group. So I just wanted to share my proofs. I'm going to do number 8 two different ways. And hopefully you can appreciate how one of them is a little bit easier if you notice it. But let's do number 6 first. So I will just copy this to where I have more space. Right, so for number 6, we have this diagram. One of my recommendations is making the diagrams nice and big. So I'm going to just blow this up. Oops. If I can click on the right thing, I will make this diagram bigger. I have AF matches BG. I have angle A matches angle B, and I have AE matches BD. They overlap a little bit. It's a little hard to see it there. But what we want to do is we want to look for the triangles hiding in this diagram that we know a lot about. And there are actually two triangles where we know three things. Hiding in this diagram is triangle FAE. And you will notice two sides and an angle of triangle FAE are marked with relevant information. Also hiding in this diagram is triangle DBG. And we've marked three things about that one. We have that AF matches BG. We have this angle matches this angle. And then these segments at the bottom are congruent. AE matches DB. So there is side angle side. It's just hard to see. If we write this up as a proof, moving forward, we do not need to worry about the difference between equal distances and congruent segments. It is okay if we're a little informal about that. AF equals BG, angle A is congruent to angle B, and AE equals BD, given. That is enough for us to do side angle side between these triangles. Triangle FAE is congruent to triangle GBD. And let me be careful about finding the congruence statements for my reference numbers. Where did I say that this blue segment is congruent to this blue segment? Step 1. Where did I say that this angle is congruent to this angle? Step 2. And where did I say that AE is matching DB? That is in step 3. I wrote it kind of sloppy here. This is an E. So now, by CPCTC, I can say that this side here matches this side here. Technically, I would be saying the segments are congruent, but that is effectively the same as saying the distances are equal. It is okay to call that CPCTC. So that's number 6. It's pretty straightforward if you find the right triangles. Now let's talk about number 8, and I'm going to do this two different ways. In the book, the point X is not marked, which means there's a way to do it without talking about point X. I'll do that way first. And the notation here is a little confusing. There are degree symbols in the diagram, which means strictly speaking, X and Y and W and Z are numbers. Right? That's why over here we're saying W equals X and Y equals Z. Those measures, those numbers are the same. So I can mark up my diagram. I know this matches this. I know this matches this. So we have a parts and wholes argument going here. So the very first thing I'm going to do is I'm going to wrestle with this parts and wholes thing. If this black part up top matches this black part in the bottom, if orange in the top, if orange in the top bottom matches orange in the bottom, then this whole angle here at R matches this whole angle here at S. But we need some steps to actually spell that out. So I have my two givens. Remember, when you're reasoning with parts and wholes, you need to talk about part plus part equals whole. You need to do addition or subtraction. You need to do some kind of substitution or transitive, although the exact order might vary. I might notice here that just by the addition property, I can add these. W and Y and X and Z are technically just numbers. By the addition property of equality, equal things plus equal things give me equal answers. But then, by angle addition postulate, I could say, oh, W plus Y, right? In the diagram, W is the measure of this angle, Y is the measure of this angle. Together, they give me the measure of the full angle VRS. And while I'm at it, I can do it on the other side. This is X degrees, this is Y degrees. If I add those numbers, I get the total of this one. And this is where we're going to notice that substitution or transitive comes into play. Measure of angle VRS in green is the same as W plus Y in purple, which was mentioned before. In step 3, we said the thing in purple is the same as X plus Z in orange, which is mentioned over here. And we're saying that it's the same as measure of angle TSR. So green equals purple, purple equals orange, orange equals brown. We can combine that to say that the thing in orange, measure of angle VRS, is equal to the measure of angle TSR. That is transitive property. So that is transitive property using the previous two steps, 3 and 4. You could say substitution, and that's also correct. A note I will make here that we do not need to rephrase things. This is the same as saying angle VRS is congruent to angle TSR. We can just do those interchangeably. You don't need a separate step. You don't even need to write this down. We now know that angles are congruent. So I'm going to go back to my diagram and say, oh, this whole angle here is congruent to this whole angle here. So now that I know that those wholes are congruent, let's mark them. Right? This one here and this one here. I might notice that there are triangles here I can pull apart. If I pull off triangle VRS, I have this angle marked, but also this angle marked. If I pull out triangle RST, I have this angle marked and this angle marked. So we're noticing we have angle, angle matches angle, angle. Well, when you see angle, angle, you think that's almost another rule. It's almost angle, side, angle. And we get that here, just by reflexive property. So now we're going to explain why are these triangles congruent. I need reflexive. So I will say that, oops, it's not blank. I will say that RS equals SR. I'm just switching the order because of the symmetry. That's by the reflexive property. And now we can do angle, side, angle. Triangle VRS is congruent to triangle TSR. Let's really make sure all the information is there. I'm going to be very careful of seeing, do I say all of these things to fill in my reference numbers? Where did I say that this angle, VRS, matches this angle, TSR? I said it in number 5. Where did I say that RS matches SR? I said that in 6. And where did I say that the angle here at S matches the angle here at R? Right, that's Y and Z in the original. That's number 2. So finally, what were we trying to prove here? We were trying to prove that RV equals ST. Once I know that these triangles are congruent, that's CPCTC. So that's the intended way of doing this problem, and it's a little annoying because you have to do all of this part and whole stuff. Sometimes that's the only option, but if we can find a way of avoiding that, we'd prefer it. So I will show you a different way of doing this problem, and it uses the X that I marked. So here's the same problem. Draw a nice big version of this diagram. Somehow my X got moved. X is actually here. As before, we know these are congruent. We know these are congruent. We are always on the lookout for congruent triangles. But we're also on the lookout for isosceles triangles. If I see a triangle with 2 congruent sides or 2 congruent angles, I know additional information. And so we'll notice here, triangle XRS has 2 congruent angles, which lets us use the base angles theorem. That's going to be really helpful. So here's another way we can do this. I'm noticing the isosceles triangle and getting it to work for me. Right? Givens as before. But now, looking at triangle RXS, I can use the base angle theorem to say that because the y degrees here matches the z degrees here, the opposite sides are congruent. Segment RX is congruent to segment SX. That comes from the immediately previous step, so I don't need reference numbers. If I mark that in the diagram, I will notice that the triangle on the left and the triangle on the right have angle side matching. When you see angle side, you think that's 2/3 of a rule. What else could I throw in there? Side angle side, but I'm trying to prove that VR and TS match. But maybe angle side angle. What would be the angles? Angle side angle. Let me do that in a different color. Angle side angle over here on the left. On the right, angle side angle. And these are congruent by vertical angle theorem. So by the vertical angle theorem, I can say that angle VXR is congruent to angle TXS. And now I can use angle side angle to say that triangle VRX is congruent to triangle TSX. And let's check our previous steps. Where did I say that these pink things match? W matches X, that's in step 1. Where did I say that segment RX matches segment SX? That is in step 3. Where did I say that these red ones match? That is in step 4. And now CPCTC, as before, finishes this for us. So this one is shorter and I think easier than the previous one if you're on the lookout for those isosceles triangles. So keep in mind, we're always on the lookout for triangles we believe are congruent, but we're also on the lookout for any triangle that has 2 congruent sides or 2 congruent angles, so we can use isosceles triangle theorem or base angle theorem. All right, there you go.